great honor and goodness gracious, it is late on a Wednesday. The honor and privilege of managing and supporting the CS for All Teachers community. And I am super excited to be with you here tonight, along with Colleen Lewis, as she is going to share with you some great tips that she's collected over the years through her csteachingtips.org work. She has been a great partner with us, and we're just so glad to have her here as part of this webinar series in preparation for CS Ed Week, which is coming up really soon. As I mentioned several times before, we do hope to hear from you, and I mean by hear, I mean literally hear. So I'm going to add in the chat box there our call-in number that you can use, or you may either connect via the audio on your computer if you have a built-in microphone. We're a small but mighty group, which means we have a real good opportunity for lots of conversation and collaboration. And so while the chat window is certainly fine, we would love to hear from you as well. So don't be shy. I mean, we really do mean that. We don't want this to simply just be a sit and get session. So I'll be back in the background if you need any assistance or need troubleshooting, and I'll be watching the chat window. But we look forward to this conversation. And again, just one more time, if you do are logged in or called in via phone, be sure to mute your line if you're not speaking to cut back on that background noise, and then just unmute when you're ready to talk. So without further ado, I'll go ahead and turn things over to Colleen. Thank you, Colleen.
Awesome. Thanks so much, Melissa. And as Melissa said, I think we're going to be having multiple levels of conversation. One is in this chat window. One is people actually speaking, so you're welcome to call in. Cody recently posted a question which was, does anyone work with, maybe Cody didn't have the but does anyone work with elementary school students? And so other folks who haven't introduced themselves, it'd be great if you introduce yourself as well as we get started. I think another, and we're recording it for people who can't attend live, right? That's, I think, an important piece. But for those of us who are here, I would love to have, one of the questions Cody kicked us off with in the chat was looking for curriculum directions for CS Ed Week. And so I would love for folks to say, hey, I'm going to be using this, and here's where I think it's important. Okay? And I'm going to dive into some other pieces that I think are important for getting ready for CS Ed Week. And in particular, looking at two dimensions. One dimension is thinking about introducing computer science to people for the first time, and that's going to be a variety of different people. And then the second is often with CS Ed, we are able to tap into volunteers and to bring volunteers into our classrooms. And so I want to talk about some strategies for how to prepare those volunteers. But I think while we're doing that, we've got a great group of people in the chat, and so I think we can share additional information about curriculum. For example, I love Google CS First. So you can Google directly that, Google CS First, and I love it. So I would recommend that you check that out as one of the options that you consider. But I'd love to see what other people have got to say. Okay, I think that I have next slide capability. Yes. Okay. Okay, we already have hit this. For most people is introducing themselves in the chat window, but I'd love to continue to have folks do that. Sounds like May teaches elementary in New York. Thanks for coming, May. And then Sabrina is middle school in Texas. That's awesome. Okay, so like I said, the first thing I'm going to talk about is thinking about introducing people to computer science. And I think that this is interesting. Often we might think about introducing students to computer science for the first time, but I think we can have much wider audiences. And so I'd love to have folks throw in the chat who are some of the people that they need to communicate to about what computer science is and who does computer science. So I think the obvious one is students, but the more I think about this type of work, I realize, other teachers need to know what computer science is. And I'd love for folks to add other ones. I now have forgotten how to say it. Administrators, families are really important. Parents are really important. Sina, thank you. I'm so sorry. Sina pointed out administrators. Another one I've found is other teachers and counselors at your school. So if there are people who are getting to decide who gets to take a computer science course, say it's an elective, I think that's really important. So So whereas these were written in mind for an educator who's not familiar with computer science, I think that these things can be important when we're thinking about introducing people to CS in general. Okay, so my first one is to describe programs or computer programming as instructions. I think this is super important to just demystify what programming is. People are like, oh, programming, it's like this very, very complicated thing. But when you can just be like, oh, no, dude, you know, programming is just writing instructions for the computer to follow. They're just like human languages. There are a lot of different programming languages, and connecting it to people's everyday experience of asking a friend to do something for them. This contrasts with what I think kids and adults often think. So do people recognize this photo? This photo is from The Matrix. And this photo from The Matrix I have used in some of my research. So I'm a computer science professor at Harvey Med College, but I research how people learn computer science and how people feel about learning computer science. And one of the studies I did was with sixth graders, and sixth graders just on the first day of a computer science class, and I was like, oh, you know, I've got all these different programming environments, say Scratch and Alice and Java and a bunch of them, and I showed them those programming environments, and then I also showed them this picture. And I asked them, is this definitely programming, maybe programming, or not programming? And more than half of my students said that this picture from The Matrix was definitely programming. And I'm like, oh, like that is, I think, somewhat problematic. And thinking about, sometimes I'll ask students, oh, have you programmed before? And they're like, no. And I'm like, oh, okay, you know, we're going to be using Scratch. And they're like, oh, I've done like hundreds of hours in Scratch. And I'm like, oh, then you were programming. Like maybe you could spend all your time in Scratch just in Paint, but probably you were programming. So I think this, what kids and adults think counts as programming is really important to set expectations with. The Matrix photo, definitely not programming. Scratch, definitely programming. Okay, so another piece to, again, tie this into everyone's everyday experience is pointing out products of computer science. And for this, I would love to hear what folks think, what connections to everyday technology interest your students. And so I would love to hear from folks who are working at that K-12 level, like what makes it compelling? If I can explain to them how a smartwatch works, or a pedometer works, or a mouse pad works, what is it that really really makes them feel like they're understanding the world around them? So I would love to have folks type that in, and I'll pop back to this for a second. Something that's really important to me about why do we teach kids computer science? You could say, oh, well, we're trying to grow computer scientists. And I'm like, okay, well, sure, you might be trying to grow computer scientists, but I think it's a more compelling case to say technology and computer science are ubiquitous. And it's important in our educational system to make sure that we are providing students the tools they need to understand the world around them. So we explain to them how the digestive system in the human body works. And we explain to them how plants grow. And I think with that, it's important that we explain to them how technology works, how the internet works, how computer science and this process of writing instructions to the computer follow underlines it all. So Sina mentions they're interested in how memes are created. And so Nicole mentions about like focusing them on how are those apps that are on their phones created. I think even once I get students to the point where they're writing an if statement, I say, oh, you can imagine, say in Scratch, the if click this character, say. Be like, oh, you can imagine that that's how an app on your phone starts up. Someone clicks on that button, and behind the scene there was a, if this button is clicked, take these actions. And Marcus chimed in, depends on age, but phone apps and desktop apps, and Pixar movies, and games and self-driving cars. Oh, I love that. And getting them to think about, you know, how big of a task is it? Excuse me, sorry. How big of a task is it to make one of these games or Pixar movies or these self-driving cars. I think one of the strategies, if you've heard of Bootstrap, which is the math and algebra integration project, and they have a bunch of, Nicole said, bless you, thank you. Bootstrap has algebra and computer science integrated. One of the things that they do is they say, oh, what's your favorite video game? And kids list off video games, and then they present information about how many years those video games take to make, and how many dollars those video games take to make, to help students set expectations about like how many people have to work together to accomplish these things. Yeah. Okay, moving on, explain that bugs are expected. So I find that I explain this when I'm teaching students to code. I find it when I explain it when I am teaching students to write. No matter what you're doing, you're going to have errors, and that's just a normal part of the process. And this relates into something that I think a lot of teachers focus on, which is helping students develop this mindset that's accepting of failure, right? That like, oh, failures, these setbacks are just feedback to help me improve my process. So on the screen here we have Professor Carol Dweck, who's at Stanford, and Carol Dweck's book, Mindset, The New Psychology of Success. And thinking in that book, and Carol Dweck and colleagues' research looks at the ways in which students' attitude towards failure shapes their behavior. So if they think failure is indicative that means they don't have some innate ability, then they're unlikely to want to challenge themselves. They're unlikely to ask questions. So we really, I think programming gives us an excellent opportunity to talk about that expectation of failure. Bugs are totally expected. Code, never works the first time you try it. And so we can, in our computer science classes, in our computer science activities, really embrace what Carol Dweck calls that growth mindset. Okay, introduce synonyms for computer science. So one thing that I find is that kids know a lot of words that are synonyms for computer science, and they don't know that they're all just synonyms. So one of my questions is, what's the vocab that your students know about or ask about? So one of the ones I hear is hacker. What's the difference between being a software engineer, a programmer, a hacker? I tell students probably functionally nothing. Hacking comes with this connotation of doing bad things, hacking into or breaking into a system that you're not supposed to. But I'd love to hear what other vocab your students are familiar with. And again, I think when we're introducing whether teachers, administrators, parents, families, students into computer science, when we're trying to help them see it as something that all students can engage with, I think it's important to demystify some of this vocab. So other ones I hear, so computer scientist, software engineer, programmer, hacker, maybe there are other ones, maybe IT. I think, maybe for someone who's some way through studying computer science or information technology, maybe then the distinction between those two things matters quite a lot. But I think for most people, helping them understand that computer science or information technology is a really broad field. Oh, Nicole mentioned entrepreneurs, right? And, when we don't often think of when someone opens a restaurant as they're an entrepreneur. We think of them just as a small business owner. But we use this phrase entrepreneur really frequently in the tech space. And I think that's interesting. So trying to take the power and alienating factor away from these words. Oh, and Sina mentioned spam and virus and hacking and programmer. And I think particularly it's interesting with all this vocab that relates to computer science, like spam and virus, demystifying that with students. So as a teacher, you're not necessarily going to know all of what those mean, but particularly in a classroom setting, you can say, hey, what is spam? Okay, well, yes, it's some canned meat, but what does it mean in a computer science context? So like typing into Google computer virus or computer spam. So including that keyword computer. Another tip is to include the word definition. So Googling computer spam definition might help you get something that is sort of human readable. Marcus added, students assume that hacking in game development is just about finding the right software tool, unlike another professional like medicine that takes some time to develop strong skills. Yeah, I think Marcus said, I think that's a really common assumption, is not sort of recognizing that this all takes work. There, I think connecting it to learning to speak another language can be really helpful, because it's like, oh, well, obviously it's going to take practice, and obviously when you're learning to speak another language, you're going to make mistakes. And welcome, Randy, teaching grades 6 to 12. So one of the things, another type of vocab I hear students being familiar with is they're like, oh, there's like C and C++ and Java and JavaScript, and I try to give students a sense of like, oh, these are just like human languages, and maybe even as an activity we might list off human languages we've heard of and be like, oh, they're really similar. You can use a lot of different human languages to express the same thing, and in computer science we're writing instructions for the computer to follow, and so we just need to learn a language that it knows, and it knows a bunch of different languages. So I find that this can be another way of demystifying computer science and programming in general. Promote collaboration and creativity. So I think in when we're designing our CS Ed Week activities, I think this is an important piece. The example before where we talked about how much money it takes to make a Pixar movie or a game, I think can help students understand, oh, my model of one person sitting alone in a room doing this all by themselves, that's not the type of thing that makes these really cool things that I see. So particularly with CS Ed Week, if you're doing just a little bit of programming, or if you're having your computer science students share out to other members of your community, parents, other students, faculty, etc., really having them emphasize that collaboration and that creativity, I think, is a good piece to present a more accurate model of the field. So I would love to have folks in the chat window throw in what are some of the other stereotypes folks have heard from their students about computer scientists. And these can be from your students, but also if you interact a lot with administrators, parents, families, etc. I think those are relevant too. So I'd love to have folks chime in with those. And I'll keep talking a little bit more as we're going, and then we'll circle back to stereotypes a little bit later. But I'd love to hear some of the specific stereotypes that your students are exposed to and how we might counteract those. Okay, number 6, this one is just a really common pedagogical technique. You know, you can imagine like elementary school math teachers work with manipulatives, with blocks, with physical coins, and the really, really common one in computer science is just doing what we call live coding. So if you're going to have students program something, show them on the screen you taking some of those same steps. This can have a few benefits. One is a lot of times our instructions for what we want the kids to do have like tacit steps. We forgot to mention that that's a step. Like, oh, we forgot to mention that first you had to open a web browser. And so by doing some live coding or modeling programming, you can capture some of that. The second piece is when you are live coding, you're very likely to make mistakes because you just, that's just what happens. Code never works the first time. And by making mistakes live in front of students, you can show students how they might respond to mistakes, both emotionally and intellectually. Emotionally being like, oh, I made a mistake. No big deal. Let's see what information the computer is trying to communicate to me about what my mistake was. Let's see what information I can extract from the computer. And then catching up with our stereotypes just for a second, Sina put boring, tedious for geeky, smart people. And Nicole put that they have to be good at math in order to program. And what I plan on doing in life has nothing to do with computers. Oh, wow, yeah. So thinking that opting out of computers is an option. And I think currently opting out of computers is a pretty difficult challenge. And so Nicole's point about being good at math in order to program, I think is a really interesting one. And I think often, this might be a little bit controversial, but I find that a lot of computer scientists are like, oh, programming teaches you logic and thinking and reasoning skills. And I'm like, no, it teaches you logic and thinking and reasoning skills within programming. And kids just naturally are already using logic and thinking and problem solving. And so I think in programming is an opportunity to practice those skills in a specific domain. And so it's not that you already need very strong problem-solving skills in math to be able to transfer those skills over into programming. It's that programming allows you to develop those skills. And computer science is a very broad field. It has some stuff that is basically just math. Like a lot of folks who do very theoretical math work, you could also call them computer scientists, and that would be totally legitimate. And so it has some of computer science is math, but plenty of computer science is not math. And then certainly to Sina's point about boring, tedious, for geeky, smart people, that was definitely one of the stereotypes that really put me off. I was like, oh, I have to be super, super smart to do computer science. And I think pushing back against that, be like, oh, lots of people do computer science, lots of things count as computer science, and we need people in computer science who are creative, who like to collaborate, that there's a lot of that for folks in there. Okay. The last one on this sort of subset is publicizing resources for learning computer science. And at this point, I'd love to have folks add in what resources do you recommend to your students. So I would love to hear what curriculum people are using, what curriculum resources people are using. One of that I'll type in the chat window is CS Unplugged. CS Unplugged is out of New Zealand, and they have a lot of activities for helping students understand computer science ideas without using a computer. So one is, in CS Ed Week has sometimes become synonymous with Hour of Code. And so Hour of Code is the idea of, hey, if we've got folks who aren't doing don't have any access to computer science, let's try and get them engaged. And what's the best way to get them engaged? Let's have them try it just for a little while. Just try it for an hour, and then you'll see that you really like it. Okay, and so CS Ed Week often has put the Hour of Code sort of front and center. And I think this year, the CS Ed Week team is really trying to say, hey, for folks who have never done any computer science, the Hour of Code is still a great option. Get them to try it. But for folks who are already doing a little bit of computer science, who want to do more than an hour, who want to be adventurous and try more, or want to celebrate what they're already doing, then let's talk about how to go further. And that CS Ed Week website has resources for having students take things further, and has a repository of various activities. So we've had folks add in a few pieces. So Nicole recommended code.org and Scratch and Khan Academy, and that code.org has some posters that you can hang up. I agree with Marcus that Code Academy is super helpful. So Code Academy has very structured lessons where it tells students in the left-hand panel what they're trying to do. All their code is in the right-hand panel. And then something that's helpful to me as an educator is whenever they have code that's not working or they're not accomplishing the goal that task is set out, it shows in red. So I can walk behind students and see if they're making progress or see if they've got an error showing in red in their Code Academy window. And that makes it really easy for me to walk around a room and spot check who seems stuck and might need a nudge or a little bit of encouragement. In Scratch, to these sort of like broader pedagogical strategies, in Scratch, one of the things kids can use is the Paint program to create new characters, etc. I find without fail, if a kid is doing something in the Paint program in Scratch, it's because they were trying to do something else with the programming in Scratch and they got stuck. So one of the things I look for when kids are using Scratch is, hey, are they using Paint? And if they're using Paint, let me intervene, let me connect with them and say, oh, is there a bug that you had that I can help you get past? Some other pointers we've got are MOOCs, like edX CS50. So CS50 is the Harvard-based course, and it uses a little bit of Scratch and then primarily C. I would say to use that mainly with more advanced students. Sina put a note for CS Ed Week. And Melissa, maybe you can pull up the link for hourofcodes.org, I think it is, and CS Ed Week. And May mentioned App Inventor. So May, is your question, can you use App Inventor with Mac iOS? And I don't know the answer to that question. I think it's all online. Oh, Melissa posted our csedweek.org in there. I appreciate that. And smallbasic.com. Oh, is a good next step after Scratch or Alice. Some other of just my opinions is looking at Alice. I think Alice can be a really great opportunity to help build your students' 3D spatial reasoning skills. If you haven't seen Alice, it's much like Scratch, but in 3D. But with that 3D spatial reasoning, students can often find that layer of it quite distracting. So it can be interesting to try to get students to focus on the code. But I think that improving students' 3D spatial reasoning skill is really relevant. Randy chimed in that App Inventor still only works for Androids. So I think you can program it on a Mac, but it only deploys to a phone. But Randy or May, you can correct me if I'm wrong. Okay. All right. I think that the best opportunity is to learn from each other, so I'd love for folks, if they think of, while we're going on, other resources that they'd recommend people use, like throw those into our chat window, because I think that can be really, really helpful. Okay, the next thing I want to do is thinking about classroom volunteers. And one, if you haven't ever had classroom volunteers in your classroom, it might be an interesting idea to reach out. What I would do to reach out is reach out to, you can use the CS Ed Week website. I think they've got a way to connect with volunteers. Another thing is to find a random computer science professor in a local community college or other institute of higher education and be like, hey, can you forward this to your students to see if anyone of them would be interested in coming and helping out? Okay, if you've ever had volunteers in your classroom, I think it can be really, really tricky. A lot of times those classroom volunteers aren't used to working with kids and aren't used to sort of the classroom norms you've established. So I have some tips that we'll go through, and we have this tip sheet online, csteachingtips.org/tips for classroom volunteers. And with this, I think it can be a helpful thing if you have volunteers who are coming to your classroom to share this tip sheet with them. Even you can share the link to this webinar where they'll hear this, although I might be honest about the ways in which they might be really annoying if they're bad classroom volunteers. So this is hopefully trying to raise the bar and make them less bad classroom volunteers. Okay, so let's run through some. Oh, and I've got 7 tips for classroom volunteers, but I bet that you've got more. I bet you have had bad experiences bringing classroom volunteers into your classroom, and I would love to learn from those experiences so that more of us can do a good job of preparing potential classroom volunteers. So I know you're adding still resources that other folks might use for curriculum, but also you can throw in there things that you wish classroom volunteers knew. Okay, my first one is when I have classroom volunteers, I want them to introduce themselves to the class. I think, in a lot of K-12 contexts, it's really common for adults to be in and out, for teachers to be observed very frequently by various members of administrators, mentors, etc. But I think showing students and your volunteer respect by having the volunteer be introduced. It's not just some random creepy person who has popped into our classroom. Like, you know, they're here for a reason, and that reason is to try and benefit you and to contribute to your experience learning. When I have computer scientists introduce themselves, sometimes I'm like, oh, you know, introduce yourself and tell the students a little bit about yourself. And some of those introductions just like directly reinforce every stereotype about computer scientists. And I'm just like, oh gosh, I needed to provide a little more prep. I didn't want you to just introduce yourself and then say how the only thing you like doing is programming. Like, that doesn't help our cause. To help students understand that that's not what's required. So I try and encourage them to share a non-computing hobby, and particularly a hobby that they might have had when they were in middle school. And I think that in general, when I bring classroom volunteers in, what I'm trying to do is push back against some of these stereotypes about who does computer science. So this is a screenshot from the TV show Silicon Valley. And I think a lot of our students have this idea that you know, they're nerdy, like we saw before, that they have to be really good at math. And we can push back against those pieces and the other pieces that might not align with the dimensions of our students' identity, their race, their class, their gender, etc. Here's, Randy mentions, I love that show. Yeah, Randy, I can't bring myself to watch it. Yeah, but I feel like it would just make me too mad if they reinforce any of the stereotypes. But okay, here's a second piece. So you might really focus on bringing students who the dimensions of those volunteers' identities align with your students' identities. So if you teach predominantly Latinx students, you might try and find Latinx volunteers who can come into your classroom. I totally dig that. Here's the catch is if you ask a software engineer, say, or someone who's working in computer science, whatever their title is, to talk about their experiences, they might not recognize that, excuse me, I'm so sorry, they might not recognize that it's really important in the first introduction to for someone to computer science to really focus on the positive. So as a woman in computer science, I have plenty of horror stories about sexism I've faced in computer science. But when I go and I have an hour with a group of K-12 kids, that's not the part of the field that I want to communicate and share with our students. So encouraging your volunteers to focus on the positive. And Sina, thank you again for the bless you. And I think in particular, you know, people are likely to have these varied experiences. So this screenshot shows the percentage of women in medical school, physical sciences, like chemistry and physics, and law school. And you can see that computer science in red was on track with these other professional fields until about 1985. In 1985, research suggests the introduction of the personal computer really began to masculinize computer science. And so we've had a big drop in the percentage of software engineers or percentage of computer scientists who identify as women. And I think with that, as the field has become more masculinized, that you have to be male to participate, you have to be antisocial and geeky, it can really lead to some negative experiences for anyone who doesn't fit with those identities of a computer scientist. So I think people might have plenty to say about the not positive, but in those hour interventions, make it explicit to your volunteers to focus on the positive. And I think that's particularly true for younger students. Okay, so here's something that I see often is some volunteers get introduced in front of the class. Hi, my name is Colleen, yada, yada, yada. And then I, as a volunteer, say, go around the classroom and working with kids one-on-one. And so one thing is, it's a little intimidating. I'm an adult, and I'm coming into their classroom, and I've been, as a volunteer, framed as an expert. And so thinking about, oh, well, but what I want for my students is to connect emotionally, connect on this individual level with the volunteers, so that power differential or that perception of intimidation is really problematic. So one of the strategies I give volunteers is to explicitly reintroduce yourself to students. So even though I introduce myself to the whole class as Colleen, when I work with you one-on-one, I'm going to say my name, I'm going to shake your hand potentially, and I'm going to ask you for your name. And then, Sina, I know I've done a bad job remembering how to pronounce your name, but then I'm going to focus on working with the student, really getting the pronunciation of their name correct. And I think it's worth mentioning to students, and we have this tip on our tip sheet, like, don't provide commentary about a student's name. A name is really personal, so really try and pronounce it correctly, value pronouncing it correctly, but don't tell the student, oh, that's a strange name, or dismiss and not be willing to learn to pronounce it. So I think when you've got folks who are coming out to your classrooms, these are probably things in your classroom you take for granted, and so I think making those explicit. And I would love to have other folks add in what other tips do you think are important to make explicit for your volunteers. Another piece to try and assuage this power differential or this intimidation is to encourage your volunteers to move to eye level. When I train my teaching assistants, I like to give a demo where I tell someone what bug they have in their code by like towering above them. And I think just that process of towering above them, of not being at eye level, makes it feel like you're not equals. And particularly when you bring in someone to your classroom, it's really important that students can connect with them emotionally. And I think one of those, moving to the student's eye level is another way to break that down. And I'm surprised to not have people put some of these complaints about how volunteers behave in the classroom, because one that I see consistently when I've had volunteers in my classroom teaching middle school kids or even teaching college students is that those volunteers don't stay quiet during announcements. So say I have all the students are working on something and I have some volunteers going around and helping students. Well, I need to make an announcement, and I might count down from 10 that I'm going to make an announcement so that everybody can wrap up what they're doing. But when I get to 10 or 0, whichever way I'm counting, I find that if I have other adults in the room, they will think what they're saying is more important than my announcement, and so they'll continue their explanation to the student. They'll continue engaging with the student. And so to the extent to which this violates my classroom norms or prevents that student that's working with this volunteer from being able to hear my announcement, which presumably is important if I'm making an announcement, I think is really problematic. And so again, with this tip sheet, we hope that this is a resource you can share with classroom volunteers to help them understand your expectations of them. And Nicole points out adults make the worst students. Yeah, I think it can be really, really tricky in the ways in which how they, even sometimes teachers might want their students to behave, but behave in ways that are different than that. I think we see that. And so the extent to which we can use this, hopefully, hopefully this CS Teaching Tips tip sheet can serve as an external resource that you can be like, oh, I got these great pieces of advice, like, hi, don't talk while the teacher's making an announcement. Okay, I think that sort of general point is so important. We added another tip, which is almost the same, which is just defer to the teacher. And so I think this is particularly true if you have volunteers who don't have a lot of experience working with kids and might not be ready to handle any kind of off-task behavior from students, etc. So just letting them know in advance what are your expectations for them in terms of monitoring or correcting student behavior. So just making that explicit, I think, can ease their concerns that if a student is off task, they either should say X or say nothing, and they've got sort of a script to use. And we've had some other people chiming in that, yes, adults are the worst students. And folks on this webinar, we wish you were talking over us. So, so again, feel free to chime in. Feel free to dial into the audio. Although, that said, we've just got a few more tips. But I would love but I would still love for anyone else who's got additional resources that they're using. Like Marcus posted about a new operating system for Raspberry Pi that you can use. That's super helpful. If people haven't heard of Raspberry Pi, it's just like a really small computer that doesn't have a case or covering on it, and so then you can plug in different things, like you can plug in a monitor and a mouse and a keyboard and things like that, and it makes it's super cheap. I think they're closer to like $50 to $100 per thing, and Marcus, you can correct me, maybe they're even $25, but it also helps students see more visually what's happening within the computer, making it not just a black box. Okay. Oh, Marcus says $35. Awesome. Thank you. This last piece relates to what we talked about at the beginning, which is explaining what counts as computer science. I find that some people that are computer scientists are like, blah, 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 blah isn't real computer science. And you can tell, I'm a computer science professor, you can tell them, oh, Colleen said that's real computer science. So sometimes people will say, HTML isn't real computer science. Well, why not? Like, why there's a whole spectrum of stuff in computer science. It's a really broad field. Why are we trying to police what counts and doesn't count as computer science? We have a lot of different breadth, and I think with that provides footholds into this like large mass of different skills that you might develop and different ideas you might get exposed to around this thing that we might call computer science or CS. Okay, we still have, we were aiming for about 45 minutes, but we can stay on with additional conversations. But I want to direct folks to both the CS Education Week website, which we have in the chat window, the Hour of Code website, which hopefully you can easily Google. We had the previous CS Ed Week Part 1 sharing, and that webinar is still available. And then we've got some resources listed here. So we've got csteachingtips.org, where we try and collect and disseminate tips for teaching computer science. So no matter whether you're a new computer science teacher or an experienced computer science teacher, you can go on there and search through some of our tips. The tips that I presented today come from our tip sheets, which you'll find just on our main homepage. You can also follow us on Twitter or on Facebook, and then just, we tweet out or post on Facebook 3 tips a day. So you can just sort of passively get reminded. I find with these tips, I know them, but putting them into practice is still, I think, a challenge. And so getting to have spaces like this webinar where we can reflect on and remember some of these tips is really helpful. So we have a few more questions, and I encourage folks to post questions in the discussion. So recommendations for non-computer activities which teach basic computer science concepts. For that, I would really go with the CS Unplugged activities. In particular, I like their instruction about binary and their instruction of the parity. So parity is ways of including extra information in any message you send over the internet so that someone can check if the message you sent was corrupted or didn't come through correctly. And they have great examples that talk through that. They also have a great drawing activity where you have one kid be a programmer and one kid be a computer, and the programmer has to give instructions to the computer, which is their teammate, to draw a particular picture. And they can only tell them to draw shapes and give those shapes sizes and relative positions. And this can just be a fun way of having kids work together, introduce the idea that computers only know particular languages, so we have to learn the ways in which we can communicate with them. And then kids draw totally absurd things that look nothing like the programmer intended, and then it's a fun way to introduce the idea that, oh, programs do what we say and not what we want, or computers do what we say and not just what we want. And so sometimes that creates bugs, so it can give you the opportunity to introduce this bug, the term bug, and sometimes these bugs are funny. Okay, we've got a few more pieces, a few more notes in here. Oh, you can have, Nicole says, you can have a student program a human to dance, so drawing or dancing. That's a lot of fun. Nicole says, I show a video of a short dance with the robot out in the hall and have the students give them specific commands to dance. Girls Who Code Club have other resources. And yeah, so Sabrina has a similarly positive experience with the binary exercise. So there they created bracelets for initials to their name to use binary code. CS Unplugged also has a binary game where you give students cards that have 1, 2, 4, 8, 16 dots on them. And then you say, flip up the cards so that we see 7 dots. Okay, now flip up the cards so we see 4 dots. And you can have them compete to see how quickly they can flip up those cards and start recognizing some of the patterns. Like if I have an odd number I'm trying to make, I always flip up the 1 dot. And Marcus says, I love the bracelet idea. And so other folks, if you've got any other links that you'd like to share, that chat will be open for a while. But for now, I would like to say thank you so much for taking some of your Wednesday evening to come and hang out and share resources. I really appreciate everybody chiming in the chat window and sharing their ideas. Thank you so much. And thank you, Melissa, for hosting this. Good night.
Absolutely, Colleen. Before you do leave, I did want to mention that we have a number of upcoming activities planned as part of the CS for All Teachers community. There is going to be part 3 that we just finalized today of preparing for CS Ed Week happening on November 29th. This is specifically geared toward elementary teachers. If you click on the link I put in the chat window, it'll take you to our community calendar on the website where you can find all of these webinars and how to participate. November 30th, there's going to be a session about diversity does not equal equity. December 5th to the 11th, during CS Ed Week, we're going to do another CS Ed Week photo challenge. There'll be more details to come. And basically what it does, though, is we're just asking everyone to tag a photo of how they're celebrating CS Ed Week with this hashtag and either post it on Twitter or Instagram. And then we'll do random drawings each day of every time, of all the folks who have shared their photos. And then we'll actually select some finalists and have a voting period, and then we'll select one final winner based on the total votes received. So it's a lot of fun. It's an easy thing to do. And then there's 2 other webinars coming up in December. So even though it's the end of the year, there is lots more that we're offering. And these are just our webinars. There's certainly lots of other things to do in the CS for All Teachers community. So we hope you will check things out and stay connected with us. Thank you all so much.
Yeah, thanks so much again. Take care, everybody. And I'll stay on the chat for a few more minutes if you've got any other questions. Oh, Marcus, so thinking about advocacy at the state level. So there's an organization called ECCP, E-C-C-P. Let me pull up the URL. And I think they have resources. That didn't get me it. I think they have resources for folks who are interested in doing statewide initiatives. Melissa, do you have any ways of, you're hosting the webinar from Ohio. Melissa, do you have any other resources on the CS for All teacher community around statewide movements?
I don't have specific ones to come to mind, but there is a the toolkit from, oh gosh, where is it? Outlier. The folks out of Chicago. I'll find that link and put it in the chat window.
And so here's the ECEP. I had the acronym incorrect. And so this is Expanding Computing Education Pathways. And then that stuff from Outlier is really good, which is an organization at University of Chicago. Yeah, so here's the, Marcus, here's one from Outlier at University of Chicago.